40 years ago, Windows launched the PC era. Now, Jensen Huang says Nvidia and Microsoft are about to reinvent it entirely. But why would anyone want to reinvent something that has worked perfectly fine for 50 years? And just how big is Jensen Huang's real ambition here? At Computex in Taipei, Nvidia CEO Jensen Huang stood on stage in his signature black leather jacket and made a bold claim: 40 years ago, Windows launched the PC era. Now, Nvidia and Microsoft are about to reinvent it. But why would anyone want to reinvent something that has worked perfectly fine for 50 years? And more importantly, can Nvidia actually pull this off? Since the IBM PC was born, the world has seen the internet, smartphones, and cloud computing, but the core logic of personal computing never changed. You have a need. You open software. You operate it. You get a result. Want to write? Open Word. Want to edit video? Open Premiere. Want to retouch a photo? Open Photoshop. The computer was always designed around the human. That logic has held for 50 years. Jensen Huang says that logic is about to change because of AI agents. An AI agent is not a chatbot. It doesn't just answer questions. An AI agent can break down tasks on its own, call the right tools, execute steps, and deliver a finished result without you touching a single button. Huang demonstrated two examples on stage. First, a user says restore this old photo and turn it into a 10-second video. The agent opens Photoshop, restores the image, generates the video, matches the music, and delivers a finished file. Second, an architect says design an exhibition hall facing the ocean, optimized for foot traffic and natural light. The agent generates the building layout in Renoir, runs spatial analysis, simulates lighting in Blender, and outputs a full set of renders. The human only provides the goal. The agent handles everything else. If AI agents are so powerful, why do we need a new chip? Because today's AI agents have two fundamental problems: they're too slow, and they're not secure enough. Right now, your AI agent's brain lives in the cloud. Every time you use it, your data travels to a remote server, gets processed, and comes back. That means latency. That means your files, photos, business documents, everything you work with is being uploaded to someone else's server. For sensitive personal or business data, that's a real problem. And in many countries, there are content restrictions and compliance issues that make cloud-dependent AI unreliable. The solution is to bring the AI agent local, to run it entirely on your own device. That's exactly what RTX Spark is designed to do. RTX Spark is Nvidia's most ambitious chip designed to date. It combines up to 20 ARM-based CPU cores, co-designed with MediaTek, with up to 6,144 CUDA cores for GPU performance, and crucially, up to 128 GB of unified memory shared between the CPU and GPU. That last part is the key innovation. In traditional PCs, the CPU and GPU each have separate memory pools. Data has to travel between them constantly, creating bottlenecks, latency, and wasted power. With unified memory, that bottleneck disappears. The result: you can run a 120 billion parameter AI model locally, handle 1 million token context windows, edit 12K video, and render 90 GB plus 3D scenes, all on a single device. The chip is manufactured by TSMC using a 3nm process with CoWoS advanced packaging. But here's what the chip is missing that most analysts haven't talked about. There's been very little disclosure about RTX Spark's dedicated NPU, the Neural Processing Unit. Apple's M-series chips have a powerful neural engine that handles AI inference with exceptional energy efficiency. Until Nvidia clearly specifies RTX Spark's NPU capabilities, the local AI performance comparison with Apple's silicon remains incomplete. The most obvious comparison is Apple's M-series chips, particularly the M4 Max with 128 GB unified memory. Apple pioneered this unified memory architecture years ago. Its software and hardware are deeply integrated. And its energy efficiency is class-leading. Nvidia's advantage is different: the CUDA ecosystem. Thousands of AI developers already build on CUDA. Adobe's Photoshop and Premiere are being optimized for RTX Spark. The Windows ecosystem is vastly larger than Mac OS. So this isn't simply about which chip is faster. It's about which ecosystem wins the local AI era. Apple isn't Nvidia's only competitor here, and this is something most coverage misses entirely. Qualcomm has been building ARM-based Windows chips for years. The Snapdragon X Elite already runs Windows natively on ARM architecture, with competitive AI performance. Qualcomm has a head start on the software compatibility problem. AMD is also moving toward unified memory architecture with its next-generation mobile chips. Nvidia is entering a market that is already contested, not an empty field. There's one more risk that almost nobody is talking about in the context of RTX Spark geopolitics. This chip is manufactured by TSMC in Taiwan, using cutting-edge 3nm process technology. In an era of US-China trade tensions and ongoing concerns about Taiwan Strait stability, that's a real supply chain vulnerability. Nvidia already faces strict US export controls that prevent it from selling its most advanced chips to China. If RTX Spark becomes a critical consumer product globally, its dependence on a single manufacturing source in a geopolitically sensitive region is a risk that investors and consumers should understand. So what does Jensen Huang actually want? Nvidia's current business is simple: sell chips to data centers. It controls over 90% of the AI training market. That's an extraordinary position, but also a dangerous one. If cloud providers start building their own chips, or AI investment slows down, Nvidia's growth hits a ceiling. The PC market ships roughly 250 million units every year. If Nvidia can establish its ecosystem there, its chips, its developer platform, its AI agent infrastructure, it becomes something far more powerful than a chip company. It becomes a platform. The operating layer through which people's daily work flows. Some analysts have suggested that if Nvidia succeeds, it could become the defining platform monopoly of the AI era, the way Microsoft defined the PC era, and Google defined the Internet era. But the obstacles are real. The price point, likely $2,000 to $3,000 for a complete system, limits mass adoption. The ARM Windows ecosystem has stumbled before. The competition from Apple, Qualcomm, and AMD is serious. And the geopolitical risks are not going away. RTX Spark's significance today is less about what it can do right now, and more about what it signals. AI is moving from the cloud to your desk. Nvidia is betting everything on being the company that makes that happen. Whether it succeeds will depend not just on the chip, but on the ecosystem, the timing, and forces entirely outside Nvidia's control.